Today, we're pulling back the curtain on the unseen engine that powers, well, pretty much our entire digital world. It's in your computer, it's in your phone, it's in the cloud, and you could argue it's one of the most important inventions of the last 30 years.
So think about this for a second. What's the one thing that connects the absolutely stunning worlds in your video games, the jaw-dropping magic of Hollywood CGI, and even the training of AI like ChatGPT? It all comes down to one incredibly powerful piece of hardware, and that's what we're diving into today.
And that piece of hardware is, of course, the GPU. But what in the world is it really, and how did it go from being a niche component to something so fundamental to all of modern computing?
Okay, so at its very core, a graphics processing unit, or GPU, is a specialist. You can almost think of it like a master artist. It's a circuit that was built to do one thing and do it incredibly well. Rapidly draw all the images, videos, and animations that you see on your screens. It's the reason your digital world looks so smooth, so detailed, and so realistic.
You know, the journey of the GPU is just fascinating. It all started back in the 90s with just one job: make 3D video games look better and run faster. That was it. But then, in the early 2000s, some very smart people had this aha moment. They realized the same design that was amazing for graphics could be used to solve other really complex problems. It was this unforeseen pivot that turned a simple gaming component into the absolute powerhouse it is today.
And that brings us right to the modern era, where the GPU has totally broken out of its gaming origins. Today, you can feel its impact in some of the biggest, most important industries on the entire planet.
I mean, the GPU's versatility is just incredible. In gaming, yeah, it's still the king, rendering these hyper-realistic worlds in 4K and making VR possible. For content creators, it slashes the time needed for video rendering and 3D animation. But then you look at AI, and that's where things get really wild. It provides the raw, brute force power needed to train the massive models behind things like image recognition and the natural language AIs we're all talking about.
So you've got to be asking, how can one single piece of hardware be so good at so many different super intensive tasks? Well, the answer lies in its fundamental design, its secret sauce, the power of parallelism.
To really get it, you have to look at how a GPU is different from a CPU, which is your computer's main brain. A CPU is like a master chef. It has a few highly powerful cores that are brilliant at handling complicated tasks one after another, in sequence. A GPU, on the other hand, it's like an army of cooks. It has thousands of much simpler cores, and each one performs a simple task. But, and this is the key, they can all do it at the exact same time. And this idea is called parallel processing. It's all about breaking a huge problem into tons of smaller pieces and then solving all of them at once. Think about drawing an image on your screen. A GPU doesn't try to draw the whole thing. Instead, it breaks it down into millions of tiny little pieces, the pixels, and tells its army of cores, okay, everyone, calculate the color for your assigned pixel and do it now. That's how we get fluid motion and complex scenes in real time.
So, how does this whole factory actually work? Well, first, the GPU grabs instructions from its own dedicated, super-fast memory. Then, control units decode those instructions and hand out a tiny piece of the job to each member of its core army. All those thousands of cores get to work at the exact same moment, and the final, combined result gets sent straight to your screen. It's a ridiculously efficient system for getting a huge amount of simple work done, like, instantly.
But, you know, like any specialized tool, the GPU isn't perfect for every single job. It has these incredible strengths, but it also comes with some very specific weaknesses.
On one hand, its speed for those parallel jobs is just unmatched. But the trade-off is that it's actually not very good at complex, step-by-step tasks, like running your operating system or a web browser. That's a job for the CPU's master chef, not the GPU's army of cooks. And that's exactly why every modern computer needs both of them working together to be truly effective.
So, we know what a GPU is, we know how it works, but where is all this technology headed? Well, if there's one thing that's for sure, it's that the future is parallel. All right, so let's just quickly recap the big ideas here. First, GPUs absolutely excel at parallel processing, hitting countless small tasks all at once. Second, because of that power, they've grown from just a gaming part into the engine that drives modern AI and massive scientific computing. Third, all that incredible performance comes from its unique architecture, that army of thousands of simple cores. And finally, and this is so important to remember, it's a specialized tool. It works with the CPU to make our devices as powerful as they are.
And all of this leaves us with a final, really fascinating question. As we face bigger and more complex challenges, I'm talking about things like climate modeling, drug discovery, and whatever the next frontier of AI is, the GPU has become one of our most powerful tools. So what do you think is the next great challenge that it will help us conquer?